I'm Anil Kumar. We are actually considering trigonometric ratios in the domain 0 to 360 degrees. But here we have a variation. We'll now consider sine of minus 35 degrees. Definitely it is not in this particular domain, but just to give you an idea, we took this example in the same series. Now what is sine of minus 35? What does that mean? Whenever we have been talking about these angles 0 to 360, they are all positive. Positive means that you go counterclockwise. But when it comes to negative angles, then means you are going clockwise direction. So sine of minus 35 will be starting from positive x-axis and moving clockwise by 35 degrees, resulting into the terminal arm in quadrant 4. Do you get it? So this angle will be treated as minus 35 degrees. Correct? So that is what it means when it is negative angles, right? Now let us answer these questions and then see how to relate the two. First one is state sine of trigonometric ratio. Since we are in quadrant 4, we know sine is positive for sine theta when you are in quadrant 1 or in quadrant 2. So in this quadrant, we expect a sine to be negative, right? Since it is in quadrant 4. This is quadrant 4. Only cos is positive here. Tan is positive in quadrant 3. Determine value of trigonometric ratio. For that, we can use the calculator, right? So you can use calculator and write sine of, within brackets, minus 35, bracket close, equal to. And then you get a negative answer as expected. So we will write down this answer as equal to minus 0.57357. Right? So another important thing to consider is that you could actually straight away write the same angle in the calculator and find the answer. Now the question is, sketch angle and label principal and acute angle. So we have already sketched the angle. Now if the angle is given like this, what is the principal angle and what is the acute angle? Now principal angle is always measured counterclockwise from positive x-axis. So that is the principal angle theta. So how much is that equal to? Theta for us is equals to 360 degrees minus 35 degrees. You get the point? Let us see how much it is. So it is 360 minus 35 equals to 325 degrees. 325 degrees. So you can see our principal angle lies in this domain 0 to 360 degrees. That is kind of the connection which we are making in this particular example. Okay. And what is the acute angle? So acute angle, as you've learned, let us say this angle is the acute angle beta. It is always with the horizontal and taken positive. So beta, the acute angle for us, is 35 degrees. Okay. So that is how you can actually answer this question. Now the last part is sketch another angle that has equivalent ratio. So to sketch another angle which has an equivalent ratio, since we have negative value here, negative value of sine is in quadrant 3. So we have to sketch in quadrant 3 with same acute angle as 35. You get the point. Only then we will have same value, right? That is an equivalent angle. How much is this angle? This angle theta is equals to 180 degrees plus 35 degrees, correct? That is equal to, again, let's use the calculator. 180 plus 35 equals to 215. So 215 degrees. Now let us check. What is sine of 215? So let's do sine of 215 equals to, it gives us a value minus 0.57357, right? So you can check this is exactly same. Therefore, that is an equivalent angle, right? So I hope with this you can understand how we can visualize angles within a coordinate plane from 0 to 360 degrees and relate them with their equivalent angles. Remember the cast rule. All are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, cosine in 4. When we say equivalent, Then we're trying to match same sine with same related acute angles to get the equivalent, right? So that is how we should be working with this kind of questions. I hope that helps. Thank you and all the best.